a powerful matrix manipulator. Matlab can also act as a powerful graphing calculator, where we can graph various different functions and make various different types of plots, whether it be a single plot, multiple plots on one figure, or a real-time plot that changes while you collect real-time data. So let's just get right into it and create some plots. We'll just create a script that creates a plot for us. And for this first plot, we're just going to create a sine wave that basically ranges from 0 to 2 pi. So our x values are going to go, we're going to have 20 x values that go from 0 to 2 pi, so this is how we'll write it out, to 2 pi. Those will be our x values, and our y values are just going to be the sine of x. And then we are going to use the plot function, which basically plot takes in two inputs. As you can see here, initially it will take in two inputs, x1, y1. So since we only have one graph, we're going to do x1, y1. So our first x is just x in this case, and then just y. It's our plot. And then from this point, this will just generate a graph for us at this point. But we can also specify the labels while we're here. So if we use the function xLabel, we can specify the label, and we'll just call it for now x-axis. And the x-axis is obviously the name of the x. Well, we're going to call the x-axis x-axis. Make sure you input it as a string because it is text, and same thing for y-label. Call it y-axis. And then we can also specify the title of the plot. And we're going to say it's plot of sine x. And then if we save this, save it, sine x, save, and then we'll run the plot, we should generate a plot of sine x. Here you can see where our title is labeled, our y-axis is labeled, x-axis is labeled, and sine goes from 0 to 2 pi using 20 points. That's just a simple graph. You can save this graph using the save as function, and you can save it as, it's probably best to save it as a JPEG or as a PNG, sorry. That way you can use it in any other type of Word editor or Excel later. But we're not going to say we don't need it right now. So that's just plotting one simple graph on one figure. You can plot multiple data sets in one graph if you so choose. So let's say we're going to keep this initial sine curve, but we want to plot two more sine curves that shift over. So the x's are always going to be the same. It's the y's that will be changing in this case. So we'll have y2, this is going to be our variable name, and we're going to shift, still sine of x, but we're going to shift x over by 0.25. And then y3, still sine of x, but we're going to shift x over by 0.5. So now we have three curves we have to specify to plot these curves in the same graph. We're going to use the same plot function. So if you notice, when we plotted xy as one set, one graph, we have to plot the next xy as another graph in the same figure. So it'll be x, because it's still the same x value, and y2, and then x and y3. You can specify that for as many graphs as you want. And since in this case we're having multiple graphs on one figure, we want to create a legend, so we can use the legend function, where the first string corresponds to the first graph being plotted. So if the first string here is corresponding to the xy graph, which was just sine of x. The second string is corresponding to the xy2 graph, which is sine of x minus 0.25. This is what we're calling it. Oops. I forgot my quotations. and the third string is for x and y3. And that's our legend. So we can save this and plot it, and we should generate a figure that has 3 graphs, as you can see, with 3 different sign functions. Notice that the legend is here specifying which one. Also notice that Matlab automatically gave the 3 different curves 3 different colors. When using the plot function in this case, Matlab will always identify the curves using 3 different colors. There's another way to generate multiple graphs on a figure, and that's by using the hold function. So we'll go back to our original plot xy, and then we can use hold on, which means we will hold on this figure and not try to create a new figure, and we're going to plot x of y2 and plot x of y3. We still have our legend. After everything is done, after you specify everything on the graph that you want to turn off hold, and then save, run, and notice now all of our graphs have the same color. We still have our legend, we still have our title and our labels. All graphs are the same color. Now we can remedy the situation by actually specifying the colors of the graphs themselves. So if you go to help plot in the command window, you'll see various different characters here. Character strings that you can use to specify the line types, whether it be a different color, whether it be different markers, whether it be different types of lines themselves. So if we were to, let's say we want to make, so here we have plot x, y, s, where x and y are the x and y values, and s is the symbol that you're going to be using to specify what type of line. So let's say our first graph, we want it to be blue. So B for blue, as you can see, B for blue. We want it to be solid. So to indicate solid line, we have a single dash. And we also want it to have diamond markers. Notice that we put all our different symbols and character strings all next to each other. Let's say our next graph, we want it to be green. We want it to have dotted lines. And we want it to have star markers for the values. And then our third graph, we want it to be red. We want it to be dashed, and we want it to have upward triangles as the markers. Oops. So we'll save that, and we'll run it. My plot must be somewhere else. Oops, where did the plot go? Let's figure, let's see. So, oh, there they are. Just couldn't find it. Oh, now we have multiple ones. See, created 2. So here's our figure. Notice that we have all the specifications within each line. Notice also to generate multiple figures, you just type the command figure into the workspace, and you will, into the command window, sorry, and you will generate an empty figure. Normally when you're creating new plots, if an empty figure is not generated, then you're going to rewrite over that past figure. If you do generate an empty figure, you're just going to be filling in the empty figure as opposed to rewriting over the past figure. I'll show you how it's done later. So that's what you can do to specify various types of labels in the plot. You can also control the axis of the plot. If you type help axes, you can see the different commands that you can insert into the plot, that you can insert to control the scaling and the appearance of the axes. You can play around with these later or use them as you see fit. So there's another type of plot we want to look at, and that's the histogram. Here you can read about the histogram and how the histogram function works. But I'm gonna use it to display the difference between two statistical functions. So we've done a lot of statistical functions up to this point. We use sum, mean, max, min, so on and so forth. You've also used the rand. There are actually two types of rand functions. There's the normal rand, which just generates a random random sequence, depending on n by n sequence, depending on what you specify. Using rand, all the numbers that generates between 0 and 1 have an equal likely chance of being selected. However, if you were to use rand n, the numbers that it displays follows a Gaussian distribution and favors more heavily towards the center. So we can see this if we were to plot two histograms using both rand and rand n. So let's say we're going to use hist, and we're going to plot rand of 1 to 1000, and we're going to use 100 bins, and that generates our plot. It's back here. So this is our normal rand function, where all the numbers between 0 and 1 have an equal likely probability of happening. And then let's open up another figure so we don't delete the previous one. See blank figure. And now let's generate a histogram of rand n where the numbers follow Gaussian distribution. Let's plot that and see how our two graphs differ here. This one on the left is the rand n graph, and this is just the rand graph. As you notice on the left one, the numbers tend to favor more heavily towards the center of the histogram. So you'll be using histograms in your homework and probably in future plotting tools in Matlab. So that's how histograms work. We're going to look at one more thing. Couple more things. The first of which is loading data from outside sources. So typically when you're collecting data, you're probably going to be collecting it from other sources, and the data might be placed into an Excel file. So you can load the data from an Excel file as long as the Excel file is in the current folder. So as you can see here, I have the sample Excel file in current folder. So if you double click, you will load that sample Excel file. And then you can click import here. So it works different on a Mac. Or import data, and we will import it as a matrix, and we can see the data that we're importing. So let's close this, and here we have in our workspace we have a new variable. We can just rename it as data. Oops, yep. And if we type data here, we can see the data that we imported into Matlab. And then from there you can plot that data if you so choose. Just an easy way to import data into Matlab. Just wanted to show you just in case that ever occurred later on. So we've looked at using functions to plot graphs, and that comes in handy when you are actually when you create your own functions and you're gathering data using functions. Within those functions you want to plot stuff. But if you just have the data already, such as the Excel file, if you just have the data already, you can use the GUI, or the guided graphical user interface, to plot. Basically make different plots. So if we open the plot tools by just typing plot tools into the command window, opening plot tools, we can first, let's make sure we view everything. So we want to view plot editor, we want to view figure palette, we want to view plot browser. There we go. So here, the center area is where our plot window is. This is where your plot will be displayed, and this left figure palette is where you can specify and arrange the subplots, as well as access the workspace variables for plotting or editing, and you can add annotations. This figure over here of the plot browser, you can select objects in the plot window, you control visibility, and add data to access. And then this plot editor at the bottom, you can change key properties of the selected objects, and you can click more properties to access all object properties. So let's try plotting our original sine function. So we're going to click the plot browser. Well, first we'll start off 2D axis because that's what we want. Click the plot browser. Let's see if we can add data. Why is it not letting us add data? Oh, actually there's no title. Now we can add data. And then we were going to say, well, we have our x and y's from before. So we'll just say our x data source is x. This is our variables from 4 in the workspace that you can see here on the right. Click OK. And then we're going to, actually now we're going to turn on the axis titles. And you can come down here and change the axis label. So just as before, we can name x label as x-axis, y label as y-axis. You can use the font, you can add text, you can basically make all the changes we've done using functions, using this graphical user interface. But like I said before, this is only going to come in handy when you have the data in a separate Excel sheet or separate variables. When you're actually gathering data within a function and you want to plot within that function, you're going to have to use the plotting functions and all the various other functions I showed you previously. So that's plotting in Matlab, just a basic introduction. It comes in handy very well. Sometimes it's a lot more effective in plotting large amounts of data than Excel is. So it's a great tool to have, and it's a great thing to be aware of.